class, so this is a video regarding quadratic inequalities or higher degree inequalities. And so I am going to start with number 15 from worksheet 2. 15 is already factored for us, which is amazing. All I need to do is start by figuring out my critical values. To do that, I'm going to set each factor equal to 0, and I'm going to solve. So this gives me 3 critical values. Hey, when I set x squared equal to 0, if I square root both sides, I get x equals technically plus or minus 0, but there is no such thing as positive or negative 0. So my first critical value is going to be x equals 0. Second critical value, a little bit more obvious, I'm going to subtract over 4 and I get x equals negative 4. So there is my second critical value. And my third critical value is going to be x equals subtract 3 divide 2, negative 3 over 2. That's my third and final critical value. So what I do for these problems is I'm going to draw a number line. And on the number line, I'm going to put my critical values in order. So all the way to the left, we're going to have negative 4. Negative 3 over 2 is negative 1.5, so then it's negative 3 over 2, and then it's 0. So this creates for me, I'm going to space this out a little bit better, this creates for me 4 intervals. Okay, so I'm going to use colors to highlight my 4 intervals. So there's the red interval, the orange, the yellow, and the green. All right, so I think a lot of kids get confused with like what I'm doing next. All I'm doing is taking a number from each of these intervals. So some number in the red section, some number in the orange, some number in the yellow, some number in the green, and I'm going to plug it in to this equation, the factored version. If I wanted to, I could get a numerical answer when I plug in, but all I really care about is my answer when I plug in going to be positive or is it going to be negative? So that's why I do this whole sign thing, okay? So what I'm doing is really just plugging in. So let's pick a number in the red section, like negative 10. If I plug in negative 10 here, negative 10 squared is positive. It's positive 100. If I plug in negative 10 here, I get a negative number, negative 6. And if I plug in a negative 10 here, I get a negative number again, okay? And when I multiply all of those together, I'm going to end up with something positive because a positive times a negative is negative. But then when I multiply it by that last negative part, I get back to positive. Negative times negative is positive. So that's the idea. Now let's keep going. Let's pick a number from the orange section. Negative 1.5, let's go negative 2. Okay, let's go negative 2. Negative 2 squared is going to be positive. Negative 2 plus 4 is positive. Negative 2, okay, let's see. Negative 2 times 2 is negative 4 plus 3 is negative 1. So it's negative. Positive times positive is positive times negative is negative. So this orange section is going to be negative. Let's pick a number from the yellow section. I'm going to pick negative 1 here, okay? Because negative 1 comes before negative 1.5. So if I plug in negative 1 squared is positive. Negative 1 plus 4 is positive. Negative 1 times 2 is negative 2 plus 3 is 1. So that's positive. Positive times positive times positive is positive. Last, but certainly not least, is going to be a number bigger than 0. Let's pick something like 10. 10 squared is positive. 10 plus 4 is positive. 10 times 2 is 20, plus 3 is positive. Positive times positive times positive is positive. Notice these don't all alternate. This is the answer. Now wait, what are we looking for? Are we looking for positive intervals or negative intervals? Since the problem says greater than 0, I am looking for the positive intervals, and this is non-inclusive. So these are all going to be open circles, and I have 3 sections to my answer because there's 3 positive sections. Okay, so my answer is going to be from negative infinity to negative 4. That's the first positive interval. Parenthesis, because we're not inclusive. Union, the yellow interval is also positive. That's negative 3/2 to 0. Parentheses. And the green section, which is 0 to infinity. So there's my answer. I forgot that they gave me a picture of a number line to do that, so I didn't use the number line. But I can copy, paste. There we go. Same story. All right, so that's the deal. Hopefully that makes sense. Let's do another one. Number 17, pretty straightforward. Let's just get everything on the same side. So 2x squared, let's do plus x. I add the x over to the left and I subtract the 3. Greater than or equal to 0. We've got a factor. 2x and x. So let's see, it'll be plus 3 minus 1 greater than equal to 0. Let me double check my work. 3x minus 2x is 1x. So I did it right. All right, this gives me two critical values. Two critical values. So my critical values are going to be negative 3 over 2 and positive 1. So I'm going to go to the number line. I'm going to plot those two. So negative 3 over 2 and positive 1. This time I have 3 intervals. So I'm going to test. Now I could plug back into the original equation after I moved everything to one side, but I personally like to plug in to the factored version. So I'm plugging in to this. Okay, so let's pick a number from the red section. Something smaller than negative 3/2. Again, I like to pick something extreme that's easy to work with, like negative 10. So if I plug in negative 10, I get negative 20 plus 3, which is a negative number. And negative 10 minus 1 is also a negative number. And a negative number times a negative number is a positive number. So that interval is positive. I love to pick 0 when I can, so let's pick 0 in between negative 1.5 and positive 1. Plug in 0, so we get positive 3. So a positive number, 0 minus 1 is a negative number, and a positive times a negative is negative. And finally, plug in a number bigger than 1. Let's pick something like number 10. So that's going to be 20 plus 3, which is positive. And 10 minus 1 is positive, and a positive times a positive is, of course, positive. So now I have to go back and ask myself, are they looking for the positive intervals or the negative intervals? And the answer to that is the positive ones, because, again, this is greater than 0. If it said less than 0, I would be looking for the negative intervals. This time our numbers are inclusive because it's an underlined inequality, so we are including these numbers in our answers. So the answer is going to look like this. The first positive interval is from negative infinity to negative 3 over 2 with a bracket because it's inclusive. Union, the second interval starts at 1 and it goes to infinity. There's my answer. So that's really it for the quadratic problems that I wanted to do, but I am going to end with number 18. This is not a quadratic problem, but it's just a sandwich notation problem that I just wanted to remind us how to do. So a couple things here. The first thing I need to do is get rid of this negative 2 by multiplying it to both sides. And since I'm multiplying by a negative number, I have to flip the inequality. So I get negative 4 is greater than or equal to 3x minus 8 greater than negative 6. Okay, so I flipped the sign because I multiplied by a negative number. And now I'm just going to solve this by adding 8 to all the sides. Okay, so I get, what, 4 greater than equal to 3x greater than 2. Divide everything by 3. So I have 4/3 greater than equal to x greater than 2/3. I personally like to rearrange this. Like I like the smaller number to be on the left. It just makes more sense to me. So that's 2/3. Now x is greater than 2/3. So when I rewrite it, x still has to be greater than 2/3. And x is less than 4/3, so x still has to be less than or equal to 4/3. So I flip it around, but if you don't, it's fine as long as you graph it right. So you know that 2/3 is smaller than 4/3. You know that the 4/3 is inclusive because there's an underline with that inequality, whereas the 2/3 is not inclusive. And you know x is between those numbers. So if you just graph it right, then you don't have to rearrange how you write the answer. But I do need the interval notation to be a parentheses with the 2/3, comma, 4/3 with a bracket. And that's the answer. So hopefully that helps with the quadratic inequalities, and then ending with just a sandwich notation problem where things are a little bit flipped around. Thanks, guys.